Okay, so first, ignore any footage you have of my toes. I apologize, but that's the way it goes. I'm recording this from home. My daughter is sick, and I apologize for not being there. As you see that my beard's come back in, right? Pretty fast. Okay, anyways, let's see what we're talking about. So first off, we are going to do this warm-up. So here's what I want you to do. Simple enough. I'm going to give you a second here to pause the video, and then you can answer the questions you see here. Take about 5 minutes to answer all these questions and make sure that you can answer them, okay? So I'm going to pause it here. I can't, that's not really pause it because you guys have to pause it. But anyways, pause it here and then take a little time to answer it. And in about 2 or 3 seconds, I'm going to go over it. Okay. The first thing you do when you check when do you check when naming a bond is when bonding, look at the elements. If it's two nonmetals sharing electrons, the bond gets called covalent. How do you ID an covalent bond? A covalent bond is two nonmetals. How do you ID an ionic bond? That will be a metal and a nonmetal. Okay? Now, you use that information for 4, 5, and 6. What is this called? Well, NO2, that is nitrogen dioxide. I see I have a nonmetal and a nonmetal. Two nonmetals sharing electrons, bond gets called covalent. Okay? So I would use nitrogen dioxide. Number 5, what is this called? Well, it's a metal, that's a nonmetal, so I would call this sodium oxide. Because again, it's an ionic bond, therefore I do not use prefixes. Number 6, what is this called? You could just say water, or you could give it the chemical name dihydrogen monoxide. Only use the mono second. You'll notice we did not use mono here, the nitrogen, but we do use it with the oxygen there, because it came second. Name the reaction types here for A. All right, so 7A, we have a double replacement. I know it's double replacement because there's 1, 2 things here behind the plus, 1, 2 things. We just switch them out, and we get a new result at the end. B, I would say that is a synthesis. You have 2 smaller things making 1 bigger thing. C, you would call that decomposition. 1 bigger thing being broken down into 2 smaller things. And lastly, we have this right here. We see that Cu, that's by itself. It's single. So we call this single replacement. Okay, so this is one of the 3 hardest things we're going to learn all year. What I will say is that people find these to be lots of fun once they figure them out, but they will be challenging to do so. What I'm going to tell you is pay attention. Rewatch this video until you get it. That's why I'm making the video, okay? So watch it. Listen. For those of you who've been struggling, especially for that last unit with covalent bonds, it's because you did not understand why. Listen to me about why, okay? And then follow my directions. Understand the why. Okay, here we go. We are going to talk about chemical equations. All right, now we talked about synthesis, decomposition, all those things already. Wonderful. Okay, so let's bring it on over here to this. Conservation of mass. Remember that matter can neither be created nor destroyed. It can only be changed. That is key. Okay? Now, if with that knowledge, we know that all the matter that is, ever was, and ever will be already exists and has existed since the moment of the Big Bang. This means that all those chemical equations, the synthesis, the decomposition, the single and double replacements, those have to be what we call balanced. In other words, the amount of matter at the beginning and matter at the end have to be the same. Think about our baking soda lab, right? The baking soda and vinegar on the left was 40 grams, and then after the reaction on the right would have to be 40 grams again. The amounts on both sides of the equations have to be the same. We call that being balanced. Okay, so moving forward, what does this mean? Well, let me find my mouse. There you go. Let's bring it on here to this. So what we see here is a equation, a simple chemical equation here. We have hydrogen and oxygen yields water. Now, these things at the start we call the reactants. Remember that word, reactants. Okay? Now, those are the reactants on the left. Over here on the right side, we have the products. All right, so reactants and products, and this little arrow is called the yield sign. Now, with reactants and products, I want you to remember a couple things that you have to pay attention to this. This is the before the reaction. This is the after. What that means is look at these H's. How many total H's would you say there are? I'll give you a couple seconds to think. How many H's do you see in this equation? If your answer was 4, you would be incorrect. And that's a little frustrating because you see there's 2 here, there's 2 here. Okay, however, these two and these two are the same two. This is the before, this is the after. Reactants, these two things mixed together, produce these things. That's why they're the same. Those H's here are also these H's here. Okay? So there are 2 total H's on the board. However, if we look at the oxygens, you'll see there's 2 here, but there's only 1 over here. Now, if these are present at the start and there's only 1 at the end, then it would look like oxygen's been destroyed. But that's not the case. And let's kind of show you how. So first off, when we're balancing an equation, we're going to keep a tally of all the elements we have. So I'm going to write a little Santa Claus here. Okay, so you'll see HO, all right, I put it on one side, and then I'm also going to put it on the other side. So we'll put this over here too. If I were you, I would be writing this down. I don't care if it's in a journal. I don't care if it's on your desk. You are going to copy down everything that I've got on here just like I have it. So I'm going to bring this down some because you weren't supposed to see that. Okay, so now what we're going to do is this. We're going to look at this equation like it's supposed to be balanced. In other words, the amount of matter at the start and the end have to be the same. So what we do is these H's and O's are used to represent how many we have here. So if we look on the left side, on my reactant side, there's 2 H's. So I'll write the number 2. All right. Now I also look, and there are also 2 oxygens. So I'll again write the number 2, and I put it next to the O. Okay. Now over here, I see I have, again, 2 H's, but now we know hidden behind that O is a 1. So we're going to put a 1 here. Okay. Now, when I'm balancing an equation, it's pretty simple. I always start from the top and work my way down. So looking up here, the H's, is 2 and 2. Are those the same number? Yes. So is that balanced? Yes, it's good. Okay, what's on the left and the right are the same. That's how equations work, right? They're equal on both sides. Now down here to oxygens, we see we have 2 on the left and only 1 on the right. Is that balanced? No. Of course not. That's 2. That's 1. It looks like we've destroyed matter. 1 of the oxygens over here is not present at the end. That's impossible. So here's what we have to do. What we have to do is this. Over here, we see this is H2O, right? There's 1 H2O, 1 water. Well, what we're going to do is we're going to bring in a second water. And we're going to bring it in by me putting a number right here in front. This is called a coefficient. Please say coefficient because you need to know that word. So coefficients go in front of the number here, and they're pretty straightforward. All coefficients mean is how many of an atom or how many of a molecule are present in an equation. So if I have 2 H2O, it literally means I have 2 H2Os, H2O and H2O. So that means 2 H2Os. So what I do here, simple enough, is once I put this coefficient 2 here, then I reevaluate how many I have. Well, I have 2 H2Os, so I have 1, 2, 3, 4 H's. So this 2 has now become a 4. Okay? And then over here, I have 2 O's, O and O, right? So therefore, this changes to a 2. Okay? Now, this is where it gets tricky, because once you add a coefficient over here, okay, you have to retally how much you have of everything, okay? But you also have to be careful, because you see these numbers down here, this bottom number down here, this is called a subscript. It's called a subscript because it's really written underneath the letters. That's why it's at the bottom, as opposed to like the exponents, which are called superscripts. Okay, but here's my subscript right there. I cannot change those. Those are stuck the way they are. Okay, subscripts cannot be changed. You can't add them. You can't subtract them. You can only change this number, the coefficient, the number in front. So what I do is, once I change a coefficient, I then retake stock of what I've got. I look at my top line first. Always start from the top and work your way down. So if I look, H's, I have 2 and I have 4. Are those balanced? No. So then I come over here to the left side. Bring the lower side up high. That's the key. Start from the top down, bring the low side up. So if I do that and I look over here, we'll see that I have 2 H's currently. I need to have 4. So what number, what coefficient can I give this? H2. I can give it a 2. Because what that means is there are 2 H2s. So simply put, that means 2 times 2. 2 H2s is 2 times 2. So this becomes a 4. Now if I look, I see I have the H's are both 4s, the O's are both 2s. This equation is now balanced. 2 H2s plus 1 O2 give you 2 H2Os. That's all it's saying. Okay? Is that this now makes sense in the sense of the law of conservation of matter. And in fact, I can lower this and show you exactly what I'm talking about. Here's the equation. 2H2 plus O2 yields 2 H2Os. You see we have 1, 2, 3, 4 hydrogens. We have 2 oxygens here. And over here, I have 1, 2, 3, 4 hydrogens and 2 oxygens here. So again, 4 total oxygen atoms, 2 oxygens, 4 total hydrogen atoms, and 2 oxygens. Again, 4 and 4. Okay, this is the before, this is the after they form their bonds. All right, this is what we mean by balance in an equation. Okay, so if that part didn't make sense, you can always go back and watch it later. But just watch this next section here, see if it helps a little bit, okay? Now, if I'm looking at this is again conservation of mass. The question is how many. You have to be able to tell how many atoms are in a bond. Now, I know that you guys know this because we worked on this with ionic and covalent bonds. However, if I'm looking right here, how many calciums would they say there are? And I'll give you a second to think. 1. That's just Ca. That 2 over here only applies to the chlorine. Okay, there are no parentheses here, so it only applies to the number right in front of it. Therefore, there are how many chlorines? 2. 1 calcium, 2 chlorines. That's because Ca, there's a secret 1 hidden down here, right? Okay, now, with that knowledge, let's come over here to this. What if we have a coefficient of 3 in front? My question for you is how many now? So if you can tell me this, you'll be in good shape. So 3CaCl2, right? So how many calciums over here? In this one specifically? Hopefully you're guessing. 3, because it says 3CaCl2. And how many Cl's are there? Well, take this number. Think distributive. So I'm going to try to use the pen here. It's probably not going to work too much. I often think about using the distributive method or property or whatever they call it these days. And what I mean by that is we're going to multiply 3 times 1. There's a 1 behind the calcium, and that gives me 3. So then I'm going to distribute to both sides of this, just like you do in math class, distributive. And that's 3 times 2, which gives me the number 6. So there are, if we're looking right here, I'll erase those little numbers, there are 3 calciums and 6 chlorines. And I know this because if I just write this out, with knowing that this coefficient over here is basically how many CaCl2s I have, that's 1, 2, 3 CaCl2s. So that's 1, 2, 3 calciums, that's what I got, and then 2, 4, 6 chlorines. That's where those numbers come from, okay? Please, 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 please know that. All right, that's key. Okay, now, it says put the following on your desk, but don't worry about that too much right now. We'll come back to that. Here's what I want you to do. On these desks, or excuse me, your sub should have, hopefully, the following worksheets, okay, to hand out and pass out, all right? And you can see them here, all right? Basically, you're going to try to answer the questions you see on the screen, and then you're going to try to balance this equation down below on your own, okay? So I'm going to suggest you pause it here, try these on your own. You'll notice there is no key, so just do the best you can, and then try to balance the equation yourself. Take stock of how many magnesiums and oxygens on both sides, and then change the coefficients to balance it, okay? So pause it here, and I'll go through the answers in a couple seconds, okay? All right. Okay, hopefully you paused it. So here's the deal. It says atoms are not created or destroyed, we know, during a chemical reaction. They're only changed. Scientists know there must be the same number of atoms on each side of the equation. So the number of atoms on this side must equal the numbers on this side. The amount of reactants must equal the products. Now, to balance the chemical equation, you must add coefficients. That's in these boxes here. The numbers in front. You cannot add or subtract the subscripts. These little two, see the little two right there? The 1 here and the 1 here. You can't change those. You can only change the number in front. How many of those atoms you bring into the equation, okay? So if you did your job properly and you looked over here, we would see that there is, assuming I can do this, 1 magnesium, and hopefully you also recognize that there were 2 oxygens on this left side, okay? Over here we should have 1 magnesium and 1 oxygen, okay? So we got our left side and our right side. So the question is always, are they balanced? To tell if they're balanced, we start from the top, we work our way down. So, are the magnesiums balanced? Yeah, 1 and 1 at the start and the end. Are the oxygens balanced? No, 2 and then 1. That means afterwards there's 1 less. That means you're destroying matter. That is impossible. So what do? We bring the low side up. Which one's my low side? Only have 1 oxygen here, right? So I gotta bring that up. So what do? Well, I throw in the number 2 because I need there to be 2 oxygens. So I'm gonna put a 2 right here. So that 2 is a coefficient. So here's the deal. When I put that coefficient, I gotta remember that that distributes, right? So that not only goes to the O, but also goes to the Mg. It goes to both of them, all right? So what that means is I now have not 1, but 2 Mgs, and not 1, but 2 oxygens, okay? So I bring that knowledge back over here. I start again, once I change a coefficient, then I start from the top, work my way down. Are my magnesiums good now? No, they are not. I have 1 over here, 2 over here. So bring the low side up, okay? So this 1 will have to become a 2. How can I do that? Well, I could simply put a 2 here. That means 2 Mgs. So that means that there are now 2 Mgs. And what do I have? 2 Mgs, 2 oxygens, balanced. A 2 here, a 1 here. That's just, it's not written, but that's a 1. And a 2 here. Now my equation is balanced. Now I have obeyed the laws of conservation of matter. Okay? And that's what you're going to do for all the questions on these sheets. There are 2 sheets you have to complete. Okay? And your sub should have them there in front of you, but just in case you were unsure, I believe I can pull this up on here. Hold on, let me see. Is it over here? Okay. So if you look in our modules, you should see a couple things. There is balance and equation worksheets, plural. They are both on here. You can click on both of them. You saw what the first one was. This, I believe, is the second one. Again, with lots of blanks, you have to fill in on your own. Okay? Don't do number 2. That's my advice. We'll do that one together when we come back together, okay? Don't do number 2, but do all the rest. Okay? You can see there's more on the back here. Always check the back. And then with the first balance and equation worksheet, my recommendation to you is, if you don't feel up to it, don't do the challenge down here. This one is tough. Okay, that one's tough. Don't do that unless you want to. And do all the rest. This one right here will be the most challenging. If I were you on this section of my sheet, I would write double the odd. Because in this one, you will have not 1, not 2, but 3 oxygen atoms right there. And so you're going to need to double the odd. Double the 1, that's odd. So there's a 2 here, that's even. That's a 1 that's odd. Double that first, and then it will make sense. So anytime there's an odd number, double the odd, and it will be solvable. You can actually use that to help solve this one down here. Okay? Double the odd. Anyways, that's all my advice. That's all you got to do. You have the remainder of the period, not only to do this, but to figure it out, work together. There's also, I should say, a bonus. So if you look over here in our modules, there should be a third worksheet as well that your sub has access to. And right here, it says balance and equations bonus. You can see right here, it is, let's just say, a lot. And this right here is worth a full 100 extra points. Okay, so I will replace any grade you have in the grade book with 100. Not a quiz, but any regular assignment. So if you got a missing assignment, right, or some low grades, I will add 100 points for free to your assignment to give you extra credit. Okay? Okay, don't be too daunted by this. Work together. It doesn't matter from there or not. What matters is that you are trying to learn this. Okay, because at the end of the day, I'm going to show up in our next class period, which will be Monday, and I'm going to expect you guys to know how to do this. Practice it, go over it, get help, but don't just sit there and say, I can't do it. Because at the end of the day, we're not, but like what? For some of you, 2 years, for some of you, 4 years from being like adults who have to figure stuff out on their own. So time to start learning. All right, learn how to learn. Take your time. Rewatch this video. Go slowly. Ask for help from partners, from teachers, etc. Okay? Good luck. Love you all. Bye-bye.